So we're doing an experiment on underwater kinematics, and these are supplies. So we have like 3 different bottles of isopropyl alcohol, 91% isopropyl alcohol, which is going to be our main fluid in this experiment. We also have this long and big container, which we already filled like halfway with our alcohol, and we're gonna fill it all the way to the top. What we're gonna place inside of it is this ping pong ball right here. We put the ping pong ball inside, and we're gonna push it down with our imaginary plunger, which is this long metal stick, which we use in order to push down on it and get it all the way to the bottom.
Or whatever height we need.
Or whatever height we need. Just in case we have this container in order to not make a mess.
Because
finally,
the ethanol will go over the top.
It will. We have this stopwatch in order to measure time. And we also have this meter stick in order to measure height. And so the point of this whole experiment is to figure out what the density of the 91% isopropyl the density of the alcohol is. Go. And here's Liliana pouring the alcohol into the container. Good alcohol pouring, Liliana.
No, Jonathan Delva got it earlier.
There it goes. You know, it's really important that we did this experiment quickly, or else the alcohol could evaporate. Right, Lo?
It does really fast, which makes for easier cleanup if you make a mess, but yeah. So, let's start.
Cool.
I'm going.
Let's not break that, please, it's not mine.
Great way to start.
Alright. Tell me when.
This is a big play Babylon for you.
Yeah.
Wow, what is this? Okay, there it is. Alright, where's the height?
Oh my god, this is my time to
Ready? When you
1, 2, 3, go. And after getting all of our results, we put in our table. And with height on the x-axis and time on the y-axis, we plugged in all these data points and we created our graph. And here's our graph with all of its points in a line. We used the with time on the y-axis and height on the x. We used a polynomial best fit line in order to find our best results. And finally, after that, we created our equation. And this is our equation.
Okay, we're going to start with our 2 formulas. We have a kinematics formula, the delta x formula, and then we have F net. In this case, it equals both ma and the buoyant force minus the force of gravity, because buoyant force is larger and going up in this situation. And so that's the one we're going to use right now. So we have ma equals buoyant force minus gravitational force, or ma equals rho vg minus mg. So then we divide both sides by m to get rho vg minus mg over m, and that is our acceleration that we're going to use up in our delta x formula. Over here we have delta x equals v naught t plus 1/2 at squared, and we plug in this a up here, so we delta x equals v naught t plus 1/2 rho vg minus mg over m times t squared, and that 2 combines to the m, so we have this new thing right here, and so that's our formula.
Alright, so we already know that our equation is delta x equals rho vg minus mg divided by 2m plus t squared plus vo times t. So we're going to compare it to a quadratic equation, and we'll show you how it relates to how we're going to find a. So x equals time in this case. A is going to be our slope, and c, which is our constant, is 0. So now we know that A would have to equal rho Vg minus mg divided by 2m. And we know our constants for volume of a sphere, for gravitational, or force due to gravity, and our mass. And finally, from our graph, we calculated our slope, which is 1.17441. And so now we're going to solve for A, or solve for rho. So we plug in our constants into our equation. And then after that, we start to solve. We simplify it.
Is the learning time. Please, if you are here to watch the film screening of the collegiate.
Alright, so now we plug in what A equals, and we start solving for rho.
Comments in 5 minutes. Thank
5
you.
minutes, team.
And we finally get that rho equals 85.23 kg over m squared.
So first we're going to find the actual density of our fluid, 91% isopropyl alcohol. The other 10% is water, and that is the density of 1,000. And then the density of our isopropyl alcohol itself is 786 kilograms per meter cubed. So the rho of our fluid will be 0.91 rho iso plus 0.09 rho water. And then we just plug in for the densities that we found before, so 0.91 times 786 plus 0.09 times 1,000, and that ends up with 805.26 kilograms per meters cubed. So then we do our percent error, which is our actual or theoretical values minus our calculated or experimental values over the actual. So we take the number that we just found, 805.26, minus the one we calculated before, which is 85.23, all over 805.26, and that gets 0.894 or 89.4% error.
And now it's time to talk about sources of error. So our first source of error was the drag force, which is the resistive force that the ball would feel as it's coming up from the water. And another one was imprecision in time and displacement, since of course we were using meter sticks and a stopwatch, which isn't exactly precise. Thank you.